and the light is diffracted at an angle theta, and a convex lens is placed to focus the light. It can be, the point P can be of minimum intensity or of maximum intensity. But we have seen in all cases, just we have seen that is center is bright, because the light reaching there in the same phase difference 0, or we can say in the same phase. So it is the bright that is constructive. Now the P. So how we can? First, diffraction, that is bending of the light at the sharp edge of an obstacle. Like, say, it is focusing the light there, and just if we take the single slit once again, though we have seen several slits, but now it is a single slit. See here, just I am drawing in that part, you will notice. Here I will try. See the differences when we use the red light and if we use the green light, then it will differ. Just I will show in between the green light also the diffraction. Now, how we can, so diffraction is the bending of the light at the sharp edge. That is diffraction. So now our purpose is how we can explain that P is maxima or the minima. For this purpose, let the slit width is A. Slit width is A. In the interference, we have taken the slit width D. Though we can, here also we can take D, but to differentiate these two phenomenon clearly, just we are taking the different representation. And theta is the angle of diffraction here. Then what will be the path difference? Path difference, if we draw the perpendicular from A, then this angle is also the theta, and it is, let it is the perpendicular, that perpendicular is N, then this one is the path difference denoted as del x. So this Bn we can say the path difference. And now if we take the triangle ANB, at N it is the right triangle. So this AB is the hypotenuse, and for this angle it will be the perpendicular. So if we find out what will be the sine theta in triangle ANB, sine theta equal to, what is the sine theta here? The perpendicular BN by hypotenuse AB. If the theta, the angle is very small, then what we can write, the path difference, if Bn is here del x and AB is A, so del x equal to A sine theta. That is the path difference. Del x is equal to A sine theta. That is the path difference. Now our purpose is to find out the condition for minima and maxima. First we will find the condition for minima. condition for minima. Let the slit is divided into two equal half. The slit AB is we divide into two equal part, AO and OB. And so what will be the path difference? The path difference between the waves, and we take here a point, let the first point M1 and another here the midpoint, that is M2. So this M1, M2 equal to AO and that is equal to OB. So the light reaching from M1 and M2 to P will be A by 2 sine theta equal to lambda by 2. Lambda by 2. Just now see, if path difference is A, light reaching there, at point P. So if we divide the slit into two equal parts, then AO equal to OB, that is equal to lambda by 2. If this path difference AN is lambda, then if we take the M1 and M2 are the 2 points, M1 is in AO and M2 is in OB, then it is also, its width is A by 2. So if for this path difference will be A by 2 sine theta, and that is lambda by 2. Now, if we use the interference now, light reaching for each point in AO, there's a point in OB for which path difference is this lambda by 2. So, the light reaching at point P from any one point lying between AO and any other point lying between OB reaching at P in the same phase, so phase difference is 0. And then now here, just if we remember the interference, if the slits are divided two equal parts, then the light reaching at P will be out of phase, that is pi. If how it is, because if path difference is lambda, then phase difference is 2 pi. And if path difference is lambda by 2, phase difference will be, that is 2 pi by 2, so it is pi. It is out of phase, so intensity will be minima at point P. So in general, what we can write in general, that is, if the path difference is A sine theta is n lambda, path difference which is del x equal to A sine theta, if path difference is n lambda, that is integral multiple of lambda, then intensity at point P is minimum, and it is the condition for minima, that is A sine theta equal to n lambda. Now we will take the condition for maximum. Condition for maximum. Center is always maxima, so here it is the secondary maxima, next one. Now let it be this angle here, a small angle we can write for this small angle, it is A theta. Now if we let theta equal to, that is sine theta which is for a small angle equal to theta, and this is equal to 3 by 2 lambda by a, means a sine theta equal to 3 by 2 lambda. So that sine theta equal to 3 by 2 lambda by a. And now divide the slit into 3 equal parts. Here, to get the condition for minima, we divide the slit in even part. To get the condition for maxima, we divide the slit into odd parts. So what happens when we divide it into odd numbers, odd parts? Let here now the 3 points, 3 equal parts, M1, M2, M3, and this point is here. So 3 equal parts. The slit is divided. Then what happens? Then what will be the, so the first two parts of the equal bits. So obviously the waves reaching at point P from the first two parts are out of phase, as we discussed here. So they produce the minimum intensity. That is the first two parts. But the third part, which is here, M2B, that is the leftover part. So some intensity of light reaching at point P. And that is the maximum, that there some brightness will be there. So in that case, what we can say, that is the third one, some intensity will be there. So in general, what we can say, in general, we can say that if the path difference A sine theta, in general form, path difference A sine theta equal to n plus 1 by 2 lambda. If the path difference is odd multiple, that is lambda by 2 here. Just see, A sine theta, here from here we can write it is A sine theta equal to 3 lambda by 2. So here it is the odd number. So here it is 2n plus 1 lambda by 2 for all n equal to 1, 2, 3. Be careful. And here what's we got for the minima? Minima, that is A sine theta equal to n lambda for all n equal to 0, 1, 2 and so on. So that here n equal to 0 is for the central fringe, and here n equal to 1, 2, 3. So center is always the bright one. Though mathematically we can take here 2n minus 1, or we can take this one 2n minus 1 lambda by 2. Here for all n equal to 1, 2, 3. But here see, if we substitute for the maxima to confine this one, to satisfy this condition, then here what should be? Here we have to take n equal to 0. But if we take this condition, that is 2n minus 1, it is also the odd multiple, 2n minus 1, then we have to take n equal to 1, 2, 3. So it is the conditions for minima and maxima.